Hi, my name is Brenton Goyea, and my project is called Cleaning Up Oil Spills. Are pomegranates the answer? Did you know that every time an oil spill occurs, millions of birds and marine animals die? It is estimated that 300 million gallons of oil are spilled into the ocean each year, and oil spills can affect the entire ecosystem. This is the reason why I became interested in this experiment. In order to begin my experiment, I needed to create an oil spill. However, I did not want to just use oil and water as many existing experiments had done. I wanted to truly replicate an oil spill. So I made ocean water by using 39 grams of sodium chloride and 1 liter of water. The reason why I chose this ratio for my ocean water is because this is the average composition of ocean water. I also added Alkanovorax borgamensis, a type of oil-eating microbes, into the water to represent the natural occurring bacteria that live in the ocean. I then used motor oil as a substitute for crude oil because motor oil is a byproduct of crude oil. For my experiment, I needed to control some variables. So I controlled the temperature of the water, I controlled the room temperature, I controlled the amount of water put in, I controlled the amount of oil, and I controlled the amount of oil-eating microbes. For my experiment, I needed to find materials that were not only environmentally friendly, but also renewable. So I chose 3 materials. I chose dispersants, oil-absorbing sponges, and pomegranate peel powder. The reason why I chose these 3 materials is because dispersants is an old method of cleaning up oil spills and has been used in many real-life oil spills. I wanted to put it up against oil-absorbing sponges, a newer method of cleaning up oil spills and has been tested in many laboratories. I also chose pomegranate peel powder because there have been many studies that have shown that pomegranate peel powder contains a surfactant that is very effective at removing oil. I took 6 beakers and added 200 milliliters of water and added 50 grams of oil-eating microbes. I then added 15 milliliters of oil to create the oil spill. I did 4 trials for each material. However, in order to begin my experiment, I needed to learn how to measure properly and get as accurate as possible. So I looked at the beaker and took a ruler and discovered that 18 milliliters is the same as 15 milliliters on the beaker. And I used this to figure out how much oil I put in and how much oil, and subtracted from how much oil is left to discover how much was removed. Before I began this experiment, I originally thought, due to my research, that oil-absorbing sponges was the best method to clean up oil spills because it is very effective at its job. However, my results have shown that oil-absorbing sponges removed a moderate amount of oil and was very consistent throughout the 4 trials. Dispersants, on the other hand, was very inconsistent. On the first trial, it removed more oil than oil-absorbing sponges, but then removed significantly less oil on the next 2 trials, and on the last trial removed no oil, which is why in my graph it is very low. To my surprise, pomegranate peel powder removed the most amount of oil out of all 3 materials and removed the same amount of oil for all 4 trials. Because of my results, I have come to the conclusion that pomegranate peel powder is the best method of cleaning up oil spills. I hope that my project will help future scientists come up with alternative methods instead of chemicals to clean up our oil spills. Thank you, and remember, when it comes to oil spills, pomegranate peel powder may just be our answer. I would like to thank Mr. Redmond, my science teacher, for helping me with my experiment, and I would also like to thank my mom, my dad, and my sister for helping me with my experiment by giving me advice and helping by supplying me with materials for my project. Thank you.